Data compression and security summary. The point of compression is to determine an efficient way to represent the same data with fewer bits of memory. Compression is important for two main reasons. The storage space on devices is limited, so fewer bits is better, and the bigger the file size, the slower it will upload or download from the internet. We know that computer memory is stored in bytes. A kilobyte is equal to 2 to the 10th, or about 10 to the 3rd bytes, and can hold about one paragraph of text. A megabyte is equal to 2 to the 20th, or about 10 to the 6th bytes, and can hold a song or audio clip. A gigabyte is equal to 2 to the 30th, or about 10 to the 9th bytes. This is one of the most familiar, as it is currently used to describe the storage size of most devices, such as laptops, phones, iPads, etc. A terabyte is equal to 2 to the 40th, or about 10 to the 12th bytes. It is possible to purchase external hard drives and cloud spaces with 1 terabyte of memory. A petabyte is equal to 2 to the 50th, or about 10 to the 15th bytes, and would be used to store social media, like billions of TikTok accounts. Let's take a look at this scenario below. Spotify has 2 million songs in its library. Each song is 3 minutes long. Each song has 40 lines of lyrics. Each line of lyric contains about 4 words. Each word on average is about 5 characters. Each character is represented by 1 byte. If we wanted to approximate how much computer storage is needed to house this information, we would need to multiply each of the values together. So that would be approximately 4,800,000,000. So we would need at least 1 gigabyte of storage to hold the music. 8 bits, or 1 byte, provides enough combinations of bits to store all necessary single characters on a keyboard. This is why a byte is so important. A byte can store exactly 1 character. It has 2 to the 8th, or 256 possibilities. Many parameters in computers are designed for a range from 0 to 256. For instance, colors. A very interesting math phenomenon occurs when using 8-bit combinations. 2-digit base 16 numbers also have a total of 256 possibilities. That means that a 2-digit hexadecimal number can describe every character that can be stored in 1 byte of data. The value of using 2-digit hexadecimal numbers to describe a byte is a key abstraction that simplifies many things on a computer, like IP addresses. The globally recognized system of encoding characters is known as the American Standard Code for Information Interchange, or ASCII table. It has no specific reason for its assignment of characters. However, it has been globally agreed to and now recognized, which is more important. Unicode is a different but popular 16-bit representation that supports accented characters like E with an accent. The ASCII table is too large to display on one slide. Below is a snippet from the table. You can click on it to see the whole table and investigate it further. It encodes numbers, letters, symbols, and punctuation, as well as non-printable commands such as enter or escape. There is an extended ASCII table version. It is the table discussed so far, but includes characters 128 through 255, which are comprised mostly of Latin characters. Encryption is the process by which a message or a piece of information is changed to read or display something different to hide the information's true meaning. During the encryption process, plain text, which is the message written in plain language, is turned into what's known as ciphertext, an encrypted text, for the purpose of security. An encrypted message can contain many types and combinations of characters that may be similar or completely different than the original message. Encryption is used when confidentiality is absolutely necessary in securing a message. The encoded message will require a key in order to be decrypted. When the key is known and the user wants to know the original message, the encrypted message has to be decrypted. Decryption takes the encrypted message and converts it back to the original plain text. All encryption methods need a key in order to be encrypted and decrypted. When an encryption method is described as a symmetric key encryption, it means that there is one key to both encrypt a message and decrypt a message. The same key is used for both. The main difference between symmetric key encryption methods and public key encryption is that in public key encryption, there are different keys used for encryption and for decryption. To encrypt a message, a public key is made and is known to everyone. A private key is only known to the user decrypting the message and is not accessible by anyone else. A disadvantage to symmetric key encryption is that since the same key is used for both encryption and decryption, the key can exist with multiple parties or companies. Trust issues and key security can be a challenge in that situation. An advantage is that if a large amount of data is being encrypted and is not being decrypted by another company, such as when data is encrypted in the hard drive of a computer, using a symmetric key encryption is a fast and efficient way of securely storing data. We've introduced the terms encryption and decryption, but we'll also mix in the terms encoding and decoding. When we use the term encoding, we are referring to the algorithm that is designed to change the plain text into ciphertext. The algorithms vary by what method of encryption is used. Encryption sends an encoded message with a key to the receiver. Then, the decoding algorithm is used to decode the ciphertext. Encoding and decoding algorithms are consistent and public information. Encryption keys are needed to secure the encoded data that is being sent and received. Encryption is necessary for privacy and securely storing data. In addition to encrypting data that is transferred from one host or location to another, compression methods are needed. Compression methods ensure that large quantities of data are able to be moved and stored as efficiently as possible. We'll review 3 types of compression methods: text compression, lossless compression, and lossy compression. Below is an encoded message that needs to be decoded. Study the clues and key to reconstruct the original message. We can begin decoding by starting with the first 2 symbols. They are both question marks. This icon here decodes to RU with another icon of a sleeping person. This sleeping icon decodes to sleeping question mark. Therefore, our first 2 icons decode to are you sleeping? Are you sleeping? By following the key, we can finish decoding the original text to are you sleeping? Are you sleeping? Brother John, morning bells are ringing, ding ding dong, ding ding dong. There are 2 main types of compression. Lossless compression, where no data is lost between the original file and its compressed state, is the first type. Lossless compression can be decompressed or reverted back into its original form. When using lossless compression, look for patterns in the data that you're trying to compress, such as repeated text in a message, song, poem, etc. Another type of compression that exists is called lossy compression. It occurs when information is thrown away to save space. Unlike lossless compression, lossy compression is irreversible, meaning that we cannot get the original file back to its original state after it has gone through lossy compression.